This is the homework help video for 5.5, worksheet 2. We're dealing with radicals. So, the first section is very similar to the first section of the last worksheet. We're doing all calculator stuff to get these. So let's do the odds together, and I'll remind you what the calculator steps are. So, number one, we have the cube root of 64. Okay, in the calculator, we have, let me clear it out, we have control caret gives us that screen that we need, okay? And we can put 3 here for the cube root. We can arrow inside the radical and put 64. You push enter, and you see that the cube root of 64 is 4. Okay, easy enough. Let's try number 3. We have the fifth root of 32. So control caret 5 here, arrow in, put in your 32, push enter. The fifth root of 32 is 2. And a reminder, what that means is, if you multiply 2 by itself 5 times, you get 32. On number 1, if you multiply 4 by itself 3 times, you get 64. Okay? So, number 5, we have the 7th root of 2,187. We do control caret. We do control caret, and we put in 7. We arrow inside the radical, 2187. Push enter. The 7th root of that number is 3. Number 7. 7 has a little more going on. We have an exponent inside the radical. So we're going to go ahead and put that in as well. We'll type it in exactly how we see it. Control caret 4 for the 4th root. You arrow inside, and I'm going to go ahead and type in parenthesis 6, 4. And then there's my close parenthesis. I just need to push the right arrow to get out of that. And then to put that exponent, I push my caret button, and then I push 2. And it matches exactly what's on your paper. You push enter, the answer is 8. Okay, so these should be like, don't miss these. These are the easy ones, right? That you'll get, as long as you just have good calculator skills. Really easy. These are the ones you don't want to ever miss, okay? Now these other ones, not as much calculator that we can do because we have variables involved. So what I taught you on the last video is when you have a fractional exponent, you can treat that, and when they're wanting you to put that into radical form, treat this as a tree that you're basically pushing over, and that would tell you the order of your numbers in radical form. The 7 is the bottom of the tree. It stays put right where it is. The 5, it's pushed over all the way over here. And those are the order of the numbers. We're going to have the radical, 7th root, because the 7's on the left, x in the radical, and it's x to the 5th power. Easy enough, right? That's the 7th root of x to the 5th. Number 11. We have a number here. Now we're not really going to do a lot with the numbers yet. We're going to keep it kind of as it is. We have 44x all raised to the 2/3 power. So right now we're just going to stay in the same strategy that we've been doing. We knock the tree over. The 3 stays here on the bottom. The 2 gets pushed over to the right. Here's my radical. It's the cube root or 3rd root of, and I'm putting 44x still in parentheses, and my 2 becomes the exponent right there. Okay, we're just going to leave it like that. There's more to do with the numbers that we'll get to later, but not right now. Okay, number 13. We have 96 x to the 3rd all raised to the 1/4 power. Okay, let's push that 1/4 tree over. We have the 4 here. The 1 goes over to the right. So when I write it in radical form, the 4 on the left goes over here on the left. The 96x to the 3rd goes inside the radical. Let's go ahead and write it in parentheses. But what is the number on the right of the parentheses? My exponent is just 1. Now we said earlier, anything raised to the 1 power is really the same stuff unchanged. So what you could do is rewrite it without parentheses, 4th root of 96x to the 3rd. Right there. Okay? Number 15, 81x squared, all raised to the 1/4 power. Let's push over the little exponent tree. We have the 4 here. The 1 gets pushed to the right. So we have 4 here on the left. So we're dealing with the 4th root of 81x squared, all raised to the 1 power. And like I said earlier on just the last problem, you can take off that 1 exponent and the parentheses because it doesn't really add any value. It's okay to leave it on, but you're probably not going to see an answer choice that has that. So let's leave that off. That's your simplified answer for that. Okay, number 17, we're almost done. 9 times x fourth, but the x fourth is raised to the 1/2 power. Now what you need to understand here is this 9 has nothing to do with that 1/2 exponent. So guess what? The 9's not going to go into the radical at all. I am pushing over my little tree here. I have my 2 here. The 1 gets pushed to the right. But these numbers that I'm coming up with are only affecting the x to the 4th. So when I write my radical like this, my 9 is still on the outside. It's not in the radical at all. Okay? My 2 goes here. So I'm dealing with a square root. My x to the 4th goes here. You could write the parentheses still if you want. It's raised to the 1 power right here. Now let's simplify it even more and leave invisible what can be invisible. We don't need the square root. We don't need that 2 showing because square root is understood with just that square, that radical symbol. If you don't have a number there, we know it's 2. So leave that off. The x to the 4th doesn't need to be in parentheses because that 1 exponent doesn't really do anything different. So this is your simplified answer for number 17. Lastly, number 19, 40x all raised to the 1/3 power. Okay, I'm going to push over the tree. The 3 stays where it is. Okay, here's my tree. It falls over to the right. So that 1 goes over here to the right. Okay, let's make my radical symbol. My tree fell over. The 3 is on the left right here. And the 40x is here. Oops, 40x. And as I saw in several examples before, when I have a 1 exponent here, I don't really need to write the parentheses. I don't need to write the 1. So I'll just save myself that step since this is going to be the same thing as that anyway. So there's the answer to 19. We will be doing more of this, getting more involved with the numbers and the factoring. So make sure you're real solid on this, and we'll see you in class.